hop back into it. Here's the thing. We wrote all these really nice notes, but if I want to write some code, ready? This is a Swift playground. There's no such thing as an Objective-C playground. People have tried to make it and they usually suck. But the playground that we get in Xcode is specifically meant for Swift. So if we want to think back to our Unit 1 stuff, remember that. If we wanted to make a program, how do we do that? A command line program, that's right. So we can create new programs. I just want to show you before we go any further that Xcode tries as best as it can to let us use Objective-C wherever we can. So if I create a new storyboard app, I can create it in such a way that it's supposed to be built in Swift or Objective-C. Do you think I can create a Swift UI project in Objective-C? If anyone had a guess? No. Oh, wait. Amazing. It won't let me do it because Swift UI is probably meant to be written in... Amazing. Love it. Okay, so when we make Objective-C apps, they're going to be storyboard apps. Going to be using UIKit. But that doesn't matter for us right now. I'm going to go back to our dear old friend, the command line tool. So the Mac OS type of app, and command line tool application. We'll hit next. We will change the language we're going to use. Xcode also supports using Objective-C, C++, and C. I don't want to teach C++ or C, so we're going to use Objective-C because that's generally the other one that you will use to create an iOS app. So let's say we've got Objective-C intro. You all ready for this? No? You're not all ready for that, like emotionally or like what's on your computer? Okay. I'm sorry? Yes, so this is a command line tool, just like we used to make when we made Hangman, all that stuff. So you go to Mac OS, you click command line tool, you hit next, and then you get the great joy of changing your language from Swift, that cuddly, familiar, wonderful language, to Objective-C. No, we're going to make a Mac OS app, not an iOS app. Command line tool, Mac OS. And then our language is going to be Objective-C. All right. Raise your hand if you are excited. I'll take it. Alex raised 2 hands, technically. So, let's hit enter and see what happens. Let's save it to a certain name and see what happens. Put it on our desktop. Cool. Let's create here. All right. So, by default, if you look on the left side, what did this create for us? Yes, it created main.m. So this is the implementation for this first program we're going to make. What I'm going to do is, in order to consolidate these things, I am going to move all of our comments into here so that I can push it to a Git repo and continue to do that. Goodbye, Playground. We will not need you for about a month now. So sorry. All right. It created a function for us. Let me show you what this looks like in Swift. Because it tries to start by creating the same exact app for us. So in Swift, blurg, I get a main.swift file, and it just prints hello for me. There's this print in the global scope of my program that'll just print when I run this program, right? So I hit the plus, I hit Command R, or hit the play sign, and then it goes and it runs it for me somewhere. There we go. Look at this. Hello world. Great. What else do you see there? The program itself executes, and then it gives you a code saying what it stopped doing. That's weird. We didn't write that code, right? That comes from the compiler. And that's important because in Objective-C, we're going to have to actually give some instructions to the compiler. So we can do this in Swift, but some of it's built in. How many of you are like loving Swift more even after this hour of talking about Objective-C? In our main function, we are going to actually have to tell it what exit code to return with. This exit code is not super important for us, but basically we can send, after we execute a program, we can send to the user, hey, just so you know, this ended in this specific way. If there was an error along the way, we could send a different exit code. The user would have to know how to use this. This is a pretty antiquated paradigm because we aren't Mac OS developers, or we aren't Mac OS developers just yet. So again, let's look again. This was a really nice way to say hello to the world in Swift. What do you think this function does in Objective-C? Yeah. This main also starts by printing hello world. How does it print hello world? Yeah. So we don't have a print function in Objective-C. You could probably create it in some way. But instead, we have this thing called NSLog. Let's look at what it says. It logs an error message to the Apple system log facility. All right, what's that? Yeah, the log facility. It's where it deals with lumber, trees, lumber. No, there is a built-in portion of this Xcode in the Apple system that'll just print these things for you. I'm showing you this just because you're going to see a lot of language that looks unfamiliar when you look at the documentation of Objective-C, but you can find pretty much for everything a direct Swift analog. So logs an error to the Apple system log facility. Apple system log facility. I don't know what that is. Do you know where that is? No? It's in California. Okay, that works. So if I run this, do I know anything about the Apple system log facility? No. I'm going to run it. Oh my God, it's an abstraction. Amazing. Well, we're running my program. Whoa, it says hello world. It says it has an exit code, but it also gives me all this crap. I hate this crap, but unfortunately we're going to see it every time we log something. Because an NSLog, what? Let me mirror that back to you. Do you like it? That's true. That's great. I take it back. That sounds really helpful. And that's because NSLog is meant for an actual system called logging, which we don't typically do that often in iOS development, or at least we haven't yet. But logging is the process of sending some feedback about your program to another source. So locally, we'll log anything at any moment, maybe an error, maybe a way for us to debug some functions. But the real purpose is to be able to say, how is my program doing? When you run an app, that runtime can actually be infinite as long as the phone will keep working, right? As long as the app doesn't crash. So during the runtime of that app, you'll have certain logging. A good example of logging that is pretty ubiquitous is actually in Firebase. Firebase has analytics. that send information to an API about the performance of the app, the usage. You might get such stuff even as time using app, number of uses of app, etc. So logging isn't just a print statement, or at least that's not its intent. You'll probably see this at some point in your professional career where, in addition to making an app, you probably need to send some centralized authority some information about that app. I promise you. Biggest one is like Firebase Analytics or Google Analytics, which I think are like being rolled into one at this point because guess what? Who owns Firebase? Yeah. Sorry? The people. No comment. Or I should not comment. Okay. So, in the spirit of doing more obnoxious things that look totally unfamiliar, this program ran when I hit play, but it's a Mac OS app. That means I could run it from the command line. In the past, what we've done is to run a command line app, we've said this command, swift main.swift. Just a built-in function called swift for our command line. You want to know something cool? Has anyone ever heard of a REPL?
Yes.
What is a REPL? It's kind of like a playground, yeah? Brief tangent. What is a REPL? It's like a playground. It's a lesser version of a playground because it only does these 4 letters worth of stuff. It only reads, evaluates, prints, and it is a loop doing that. So it's just a simple program where you put in some code, reads and prints, read, evaluate, print, and it does that on a loop. This is another important thing because most coding interviews will be in a REPL, not in Xcode. So you're going to have less functionality. Some examples. I tried to use this, I think, once, and it sucked. Coderpad.io is a way for you and someone else to both be in the same page. REPL.it is another REPL. I think multiple people can be in that as well. So we should know what a REPL is. And here's a fun thing. When you just hit the command swift, whoa. It opens a Swift REPL for you. So var A is 2, var B equals 3, var C is equal to 2 plus 3. So there's a built-in REPL in your command line for Swift. Unfortunately, how do we get out of here? No. How do we get out of here? Swift REPL, exit. Yeah. All right. Don't worry about it. That was scary, though. There is a built-in REPL for Swift. You can do all this Swift stuff. What there is not, yet again, is an Objective-C REPL. But in our last bit of language-agnostic programmery things, you can build an Objective-C function, an Objective-C program from the command line, and you can then run it using something called an executable. So you'll see this sometimes. This is a way of actually passing a program as a file to someone else. It's weird. Instead of sending my code, I could send you an entirely compiled Objective-C program. Let's check this out. Got our REPL. Now, let's talk about compilers. Swift has the Swift compiler. Let's end that conversation there. Objective-C has a compiler. What's that? Oh, tell me more. Thank you. Objective-C has a compiler for multiple languages, built by Apple actually. Called Clang. And if you really are excited, both of these communicate with a system called LLVM to actually run your code. The compiler is what takes your code in your file and what takes your code in all of your files and turns it into a program that can be run. So when we build, we are compiling our code. We aren't actually running it. Running it is a different program. So these 4 words, REPL, Swift compiler, Clang compiler, and LLVM, you actually use them all the time without knowing it. You'll need to know that they exist though, because they're actually all written in code that you can see, you can find, and you should be familiar with. It'll help you debug things if you figure out what's telling you you have bugs. We don't need to get too far into that, but here's a really exciting thing. I'm going to go into this Objective-C intro, and I'm going to look around. I'm going to go find my main.m file. And what I can do is, just like I did with Swift before, to build and run a program or to get into the REPL, I can call the Clang compiler. This is weird, but it's fun. I promise you'll like it. You don't actually have to use it at all, so that's also fine. But just know that you can compile your own programs from the terminal, from command line. For some build processes in certain companies where you have to run this program before you actually run the Swift code, you'll need to know how to use a compiler. And here are just some, important commands. So my commands are using the Clang compiler, format for Objective-C this file called main.m, and call that file, once it's compiled, exec1. So I am compiling all the code from main.m into this file called exec1. When I do that, I'm going to create a file called exec1 that I can run as an Objective-C program. So I'm literally using the compiler, something we've taken for granted all the time, to create something called exec1. If I hit my ls here, I see there's this thing in red called exec1 because my computer doesn't know what to do with it. But what it is the compiled code of main.m. Amazing. Now all I should have to do is just access this file. This command is not going to work. Can someone tell me why? Albert, what's that? Gotta open it? Let's see. I'd like to update. No. Yeah, I could open it. Awesome. What does open do? Yeah. So open is interacting with this file called exec1. It's just trying to take out whatever is in there. And what open actually does is it goes and it looks in a file and it says, let's do whatever is in there, right? Open isn't a command that you've used to run Swift code or to use Markdown. It's just a general thing. Judging by the file extension, it tries to do what you tell it to do. But there's also another way to do this. So does anyone know what this means? Let me type it again. Ready? So that's what we've taken it to mean, is everything or all. What it actually means is in this present directory, let's do something. So, for example, if you look at a README that has an image on GitHub, the way you'll say to find a file might be its location is everything or the entire space, all programs and files in here. Look for something like images / I don't know, like raspberry.jpg. But this dot is actually a command to terminal. And it's saying it's a command to terminal. It's not just everything. It's a command saying interpret in the best way that you can this file. That might just be a location for a JPEG. But for our executable here, it's going to try to run it. So I can open exec1, which is going to open a program in a separate window. But to actually run an executable, I can trust terminal to do that for me. I can just say, execute that thing.
Is that the only commands we run?
Yep. Can create an executable file using the clang in terminal. All right. Well, here's the thing. We've talked a whole bunch about supposedly how this thing is working, but there's a lot of code written just into this main function. Let's look at what looks to be, what does this top line look like? Line 13 of the function. Say that again? It does look like a method, yeah. What's like the term for usually the top line of a function? Like I'll usually write something like func. The signature, yes. Let's look at the signature. What do we see in the signature? What does that int at the beginning mean to you, Levi? Yeah. So actually the signature starts with, our signature starts with the return type. This returns what type? Yep. It is a lowercase int. Our types are not the same. Isn't that scary? What's next after int? So the file is not main. What is main? Main's just the name of the function. Okay. Cool. All right, maybe now it's looking a little more familiar. Jason, after main, in those parens, what do you think those are? I agree. In parens are arguments. What do we notice about those arguments? How many arguments are there here?
2.
There are 2 arguments. Yep. So for these 2 arguments, what do we know about those arguments? What must they be? One of them is, Tia? Okay. This first argument here, what do you think its type is? Yeah, I agree. Int. And then this second argument, what do you think its type is? Yeah, it's a character that is constant. That's important because of this star. This star, let's go back down to here. This star denotes a pointer. Bar, 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 bar.
Oh, so that's a pointer.
That's a pointer.
Ah.
So one of our arguments is just an int. The other one, pointer. How do we feel so far? It's fine. This auto-release pool is doing some magic for us in terms of what memory is being used. Then we've got this NSLog. Let's talk about how NSLog works. NSLog itself does not do all the work of printing for us. And by that I mean it can actually only take a string. And you have to tell it where and when to insert other types to be logged out. So this @ sign right here denotes a literal. Talk more about literals next time. But for now, what we have to know is if I don't have this @ sign, it's not going to let me use that string as a string. String literal must be prefixed by @. And part of the reason for this is there is no type inference in Objective-C. Can't say var a is equal to 1. So we have to do this thing where we say there's going to be some stringy thing right here. Don't worry too much about what a literal is until Thursday. But there is no type inference. Rod, I want to create a variable a that has the value 1. I can't just say var a is equal to 1. How can I do that? I'll put the type first. Cool. What type do we want it to be? Amazing. Now, what do I want to do with it? All right, what's the name going to be?
A.
Awesome. And how am I going to give it the value 1? Amazing. Let's see an error we get right now. You didn't know that. But here's a really terrible thing. It's going to upset you all the time. To end a line, we must put a semicolon. Must. Compiler error otherwise. Okay. So this NSLog ends with semicolon. This variable ends with a semicolon. Returning this actual function, because remember, it returns with the exit code, which is an int, requires a semicolon. I'm sorry. Unlike what you might see with JavaScript, for example, blocks, which are what we just call basically closures in Objective-C, don't need a semicolon. They do sometimes in JavaScript, if this looks familiar. So anytime you do some work on some line, you will need semicolon, but also the compiler is going to warn you. So it's not like JavaScript where you can crash later. Compiler is going to say, there's no semicolon, you're not going any further. All right, we've declared an int here. I'm going to send a message to the user. Here's what I can't do. I don't have string interpolation. Come on. It prints out literally what I had there, except for this escaping character, which didn't hit anything. We can't do that anymore. Are you guys okay with that? We'll just never print anything, right? It's fine with me. Well, here's a format we're going to have to get used to because it comes from C languages. In order to print stuff, we have to use string formatters in text with the values afterwards. Sorry. What does that mean? Well, if we look at NSLog, it starts with a string, this thing NSString, which is a string, in our case, a string literal. But it also takes some arguments afterwards. That ... means that we could technically have as many arguments as we could fill in our lifetime. So this NSLog I have down here, I could add another argument to, and I could say I want it to print A. And then what I have to do in line is I have to, I'm really sorry, put a %, and then I have to use one of these, what we call string formatters, string flag formatters. You'll see it called a bunch of different things. I have to say %, and then here will go the value of something. This %d is different than %f, which is different than %at, which is different than %d, and so on and so forth. There's your type, your strongly typed variable, to be interpolated, has to be interpolated at the right spot for it. So let's do this. So I declared an int. Let's print it using formatter f, and print it using formatter d, and print it using formatter @. And so here we have 3 different places in which A is going to be printed, which means we need 3 more arguments. So the order in which you see these string formatters is the order in which the arguments are going to be printed in them. So if I have, let's say int, well, let's do this after. But let's print this and see what we get, because the formatters do matter. Oh no, what happened? Oh no, it crashed. It said I need to do this in a specific way. So the formatter for a float or a double or any integer, or any not integer, let's not do that. Float or a double or any decimal is this %f. Decimals. And then let's look at its suggestions again here. Format specifies type ID, but the argument has type int. Interesting. What does that mean? Well, we'll find out in about 2 days for ID, which actually just relates to objects. And then the proper formatter for an int was this D right here. I know. It's pretty awful. All right, now I printed it. I declared an int. Let's print it using formatter D. Great, it got an int in there. What also is like a warning but didn't crash my system here? Tia?
I have a question.
Yep, let me get an answer to this question first. I see a warning. What do you think this warning is going to be for, Aaron?
Well, it has to do with the first part of the beginning part, the objective C sign is not, like there's a syntax thing.
There's something syntaxy going on, but it's just a warning. It's not an error.
Oh,
Answer. Yeah, it's warning me that there are going to be these multiple arguments, even though I only use one value. When we call it interpolate it, we can say format this string. It's more accurate in Objective-C. So this won't crash, but I'll get something that's basically like, you didn't use this argument, you didn't use this variable. Hate you, why'd you do that? Question.
F is for decimals, so these things don't, like it doesn't mean double or like the same, like what does it stand for?
It stands for float.
Oh, okay.
Yeah. So the standard decimal in most languages is a float. A double just means allocate double the memory space to it. Cool. How do we feel so far?
Wait, so percent D is for ints?
Yep. We did it. Rod.
Zero for strings.
Yes. And when we talk about pointers, we're going to see how strings actually work. Because, great question. Let's do a loop first, and then we'll give a preview of Thursday, and then we will get out of this very warm room. So, I want to just jump back real quick to my characters. What is this stuff? I've got this argument, character, star, argv. Oh, it's an array of characters. Interesting. So I want to hit 2 points here. One is that Objective-C has basic types. So this is stuff whose implementation you can't really see. It's just built into the language. In Swift, we could see how an int gets implemented. All of that is open source. We could see how a double gets implemented. We could see all these things. Nothing is magic in Swift. In Objective-C, the basic types are kind of like magic. Those basic types are generally these lowercase things that look almost like keywords. So an int, a car, a float, there are these things called basic types. Some people call them primitives. Primitives are actually a little different than basic types. That's okay. We don't really have to worry about that. But generally, if there's a lowercase type that you can declare your variable or constant as, that is one of the basic types. So for strings, we use car to indicate some basic types, but almost always we're going to use something else. This string here is not a car. It's a different kind of thing. It's an NS string. We'll talk more about that next time, even with a brief history lesson. Sunny. Okay. Okay, cool. There are basic types. Then the rest of the types need to have a reference, memory. What do you think that's called? So the rest of them, they are classes. There's one word that we were asked to learn before next time. Which word do you think applies here? Yep. So this reference comes from a pointer. This star right here saying there's a pointer to some array of characters that we will call argv. Do we all continue to want to use Swift?
Yes.
Okay. Sunny.
Why are you using a pointer there if it's a basic type car?
Because the pointer is actually to an array of cars. So this is a weird setup for declaring stuff, but this constant called argv is not a character. It's instead an array of characters pointed to at the variable called argv. It stinks. I hate this. But we're going to see next time you don't have to use this setup. This is how you can use basic types, but there is something called an NS array, which is going to look much more familiar in how we create arrays. I promise you. Are you up?
Since this is a basic type of characters, so that means it takes in multiple different type of characters, like strings, ints, well, obviously not int, but
Yeah, a character is anything that can be created from Unicode. So whatever we think of it as, it's the building blocks for a string, anything you can type into a computer that can be generated from putting together some Unicode scalars. Same kind of concept. Tia, can you say a letter?
Can we do matrices?
Oh, yeah. Yes, we can. Thank you for asking. I'm so excited.
Does it have to do with like adding another, like the argv to another pointer, like multiple vectors?
Oh, like that? I don't want you to worry about this right here because we're almost always going to use something from Foundation called an NS string. So if you recall in like a playground, if you don't import UIKit or Foundation, you actually can't even create an array using like capital A array. That's because that stuff is all built into Foundation. And Foundation for Objective-C is pretty much the same thing, except namespaced with this NS. History lesson next week. Don't miss it. It's going to be so great. All right. One last thing I'd like to show you. If this argv is an array, we could probably loop through it, right? So here's the start of a loop, because a for loop is going to work in a way that we're not familiar with. Not all familiar with, or a better way might be that David didn't teach because it doesn't exist in Swift anymore. To write a for statement, we need 3 arguments. We need to initialize something that's going to be used in the loop. Looks like JavaScript. This is called the C-style loop. What?
is that where JavaScript got it from?
Yeah, I think everyone just stole every language feature from C until they wanted to add to it. Like if we're going to be philosophical, like every language is just building on C in the last 40 years, even if it doesn't implement C. But I don't want to be philosophical. But yes, in pretty much any other language, you're going to see this construct where you've got a loop, you set a condition that stops the loop. So until this condition is true, continue the loop, and then you set up some increment for the loop. So you say, you don't get to say for, let's say, for I in 1 to 5, instead, I'm sorry, let's see how this breaks. And what flag do I need? What do you think? What is A in here? Or I'll call it I. You should more typically see that I. It's an int. So what flag am I going to have to use to get this I into my string literal? I agree. So if I just want to print the numbers in this loop, let's say the loop here is that. Interesting. To have an int in front of I. Oh man. Wow. So I don't even get a shorthand for I here. So every time I declare a variable, I have to give a type annotation. I'm really sorry. Let's look back. So a C-style for loop has 3 arguments. First is initialize the variable to be used in the loop. 2 is set a condition that remains true for the loop, aka if this condition is ever false, stop the loop. And then the third one is increment our initialized variable. So sorry. But so we create, let's say, an int int a is equal to 1. Then we say a less than or equal to 5. And then this I++ just means increase by 1. So whatever the value of a at each loop is, increase it by 1 before you go to the next loop. I should probably use the same variables for all the things that I'm looking at. All right, so let's log it again. Liana? There are. Would you like to see one? All right. Sorry? You know what? Let's do that at the end of the lesson, which I guess is coming up right now. But we can definitely get an infinite loop using this format because we have to be careful that A, this comparison here is ever false, and B, that we are like changing stuff to make it false. Ready? All right, let's run this. I ran it already. Oh no, I didn't put anything in the string. So I need a formatter. Oh, cool. So my program, this print statement that Tia said she loved, is telling me at each of these lines, here's the thing. Here's the loop at this point. I got a 1, then I got a 2, I got a 3, I got a 4, and I got a 5. Amazing. If we've got for loops, we've probably got while loops. If we are coding stuff based on conditions, what else do you think we have? If. We have for loops, while loops, we probably have control flow as well, because evaluating this condition is kind of the root of that. So inside of my for loop, I'm going to say if A is even, go ahead and print A. What do you notice about an if conditional here? There's one slightly different thing than what we do in Swift. Yep, it's got parens. Our conditions to be evaluated must be in parens. So whatever is contained within this parens is the entire condition to be evaluated. I've got a lot of the operators I'm still used to. That's nice. Let's run this guy. So if A modulo 2 is double equal to 0, we'll print it. Our for loop, our if statement, a little bit different formats, but they work in the same way that we're used to. Unfortunately, with a C-style for loop, we still have to be explicit. I think that's as far as I'd like to go. What are some questions you have? Rod.
So the third argument in that for loop, it doesn't have to be incrementing, does it?
Doesn't have to be what?
Does it have to be incrementing the value?
Like that?
Well, could you do anything else?
You could totally do anything else. I could count backwards. I could say, so long as A is greater than 1, and then I have this handy operator, A minus minus.
So what if it goes up and down?
Generally, you would use the loop only to go up and down. You might measure this against something like, say we had star.count. If we had an array of stars in stars.count. Like, instead of saying we no longer have iterable as a protocol, instead we now have to say, here is the amount of times you should keep running this loop until. So we need a condition there. So it's always going to be numbers. It's no longer going to be looking at objects when we set up the definition of this loop. Sorry. Ayula and then Tia. No, we're not going to do arrays today because they're their own type coming in from Foundation that we need. Trust me.
How would you write, like,
Sorry. Go ahead.
someone else?
Yeah.
How would you indicate, like, you want to loop through and print something 5 times?
Like this? Or just print like,
The same thing.
yeah, I don't need a formatter in here. And just say that.
Would you still have to have something in the first parameter?
Yeah.
It just wouldn't matter what that is.
Yeah, so this thing I'm declaring in here is going to be available in this scope, but it's also what we should be adjusting. So for each of those 3 arguments, what we initialize should be what we test against the condition, should be what we increment as well. What's that? Yep. But this A is determining the starting point, the ending point, and what to do in between. Tia.
Maybe I missed it.
Yeah.
But the return?
This guy?
Yeah. What's going on there?
So main is a function that has to return 0 because just like we have to type annotate by starting the line with, the type of a variable, for a function, we have to say the return type first. So the signature is a little different than Swift. Instead of an arrow to the return type, we start the line with the return type. So this main function, when we just got it out of the box, said return 0. We didn't write that. We didn't do that for any reason. It just is the way that a Mac OS app is built. It needs a return type from its main function. We could try to change this, maybe to void. And then I'd have to get rid of this void, this main right here. And when we run it, we'll see something. It still is looking for an exit code. So we want to provide that exit code. I don't know. Thank you for the question.
Wait a second, so didn't it just break the for loop?
What's that?
I'm sorry. Didn't it, because we said run the for loop as long as it's like less than 5 or whatever, and it went more than 5 times, right?
No, it goes 5 times. Got 1, 2, no worries. It's kind of dense to read all this. 3, 4, 5. Liana?
The semicolon, like, I'm just a little confused as to like where that comes into play and where it doesn't come into play, because I can see that in the for loop, we can pull out, like, after the condition, there's a semicolon, but like, at the end of the for loop, there is no semicolon.
So like here?
Yeah,
Yeah, so you don't need a semicolon for the end of a block, basically.
okay.
Block being like a closure looking thing. Otherwise, even within here, this is a self-contained expression that has 3 more expressions in it. Which is a weird way of saying we've done 3 different things within this space. Normally you could just, like we did with this condition, put one thing inside of parens, and that's just one, I just had the word, that's one thing, expression, thank you. But inside of a for loop, it expects 3 conditions. Like it literally needs, 3 expressions. It needs 3 expressions. One saying again, what do we initialize? The next one saying, what should we wait to see? Or what will turn this false? And then the third saying, how should we change the variable? So this whole setup in here is actually like still doing Objective-C stuff. It's saying end an expression at this point right here. Every line that is an expression needs a semicolon. A block is not an expression. A block is like a group of self-contained functionality. Objective-C does all the same stuff. Okay, so next time we're going to get more into what pointers are. We're going to make it so that we almost never have to use this setup to make an array, but instead we can do something a little more familiar. We're going to talk a lot about foundation and maybe a little bit of history. History is okay, I promise. If we forget history, we're doomed to re-elect an orange person. Any more questions? Okay, who wants to see an infinite? Oh, sorry, Jack.
So I'm just wondering, array, because this is because Objective-C is a superset of C. I'm assuming that arrays are of fixed length.
Oh yeah.
So if I want to create a dynamic array, I'm gonna have to use pointers or involve.
That's where NSArray is going to come in for us.
Or I can create a list.
You could create a linked list. Wow. Because of these problems with dealing with memory? Yeah. So we're going to talk about how arrays exist in memory next time. Sorry. Any more questions? Who wants to see an infinite loop? All right.